At this time, we are going to focus on security intelligence. Security intelligence, abbreviated as SI, is a special engine that is designed to quickly drop certain communication based on the, as we will see in just a second, information from Talos, primarily information collected by Talos. So the logic here is that the engine is supposed to know about malicious sources, and it is going to be specifically IP addresses, individual URLs, or maybe entire domain names. It is going to know which of those addresses, URLs, or domains are bad, and it is going to drop the packet when it is destined to this malicious address or URL or a domain. Okay, as I said, those will be eventually identified by Talos, part of the Cisco's collective security intelligence, where the goal is going to be to use this information to provide an early dropping traffic mechanism. So as opposed to the pre-filter policy, which is generally used to make exceptions, like when you want to fast forward certain packets without inspecting them with other engines, security intelligence is meant to quickly drop communication for situations like if there is a new threat that was just found for which there are now signatures available. So before Cisco releases a new signature, a new IPS update, they will push the information to the security intelligence database, and assuming that the updated SI feed, you will eventually learn about this malicious source, and this way be able to drop the traffic. As you can see, the SI checks, they happen pretty early in the firepower packet processing. Initially, the device is going to be looking at IP address, and then at some point later, it will try to drop based on the URL or a domain name information. Now, why do we have three separate options for SI? And this is primarily because more than one website can be hosted on a single IP address. Like when we have a web server that is hosting three different websites, a good website, another good website, and one contains malware. If we were to block based on IP address, we would immediately block communication to all of these three sites. So what we can do instead is that we can specify individual URL, like if we want to affect this particular website, this resource, or maybe if there is a domain that contains multiple web servers where every single resource is bad. Let's say this is going to be IP2, IP3. Instead of specifying those individual addresses or websites, we can just drop the entire traffic to the entire domain. And how could it be done? I'm going to explain this later in this session. Okay, now the way that SI gets the information about those malicious addresses, URLs, or domains is primarily through the so-called feeds. So a feed is just a cloud-based service maintained by Cisco. Assuming that your device is configured with the thread license, you will be able to connect to this feed and this way get the information maintained by Talos. Another method is going to be to add entries manually. You can build static lists for those IPs, URLs, or domains, and you can essentially blacklist, which is how you will drop the communication, or you can add those entries to the whitelist, which is how you will bypass the security intelligence, but you will still go to the access control policy. You can do this manually. Now you can specify those objects one by one, or as we will see, you can also upload text files with multiple entries defined. Okay, for the blacklist type of a manual list, the default action is going to be to block those addresses or URLs, but it is still possible to change it to monitor only, in which case you will still log the communication for affected addresses as blacklisted, but you will allow the packets to the access control policy. So this is good for pilot-like deployments when you want to see what would happen if you were to actually use blacklist for real. A key takeaway, as I mentioned, whitelisted or monitored communication still goes to the ACP. It's not like when you say that you want a whitelist, you will allow the packet without further inspecting it. Okay, it is also possible to use this functionality, the blacklist or whitelist, directly from the connection event viewer. Like if you want to quickly drop communication to a malware site, or maybe traffic from a malware site, or maybe you want to bypass the security intelligence for certain addresses, just go ahead and open up the connection event viewer and then right click on the selected address. I'm gonna have some entries from the previous video. Like if I were to click on this address, right click on it, I can say blacklist IP now or whitelist IP now. So when you click on one of these options, it is gonna add the address to the so-called global whitelist or a blacklist. Okay, in order to configure security intelligence for IP addresses or URLs, the first thing that you should actually do, assuming that you have a thread license activated, you will want to update the feed from object and object management. Maybe let's quickly look at this. I'm gonna go to this portion of the GUI. The reason you will want to update the feed is so you can choose the information from the feed as your condition in the security intelligence policy. Because if you start with a brand new device, you will have no information collected. There's going to be no entries from the Telos cloud. The global blacklist, whitelist will be empty. This is why you will want to just update the feed. Or you can also add it. You can say, how often do you want to update the feed automatically? Okay, so when we update the feed, it means that we will have those different categories that we can then use in the policy. We will have to go to the access control policy, then access control for this device. For my FTD, and we will go under Security Intelligence tab. Now, since my feed was updated, I should be able to choose the cloud downloaded information from this left-hand portion table. So those are those different categories that you can choose as a condition, like known bogon addresses, known attackers, known phishing addresses, and so on. Most of this stuff is dealing with websites. You can also specify individual addresses that you want to add to a whitelist or blacklist. And you can also add your zones as a part of the condition. Like in our case, let's try to ping from 2 to 4. I should be able to ping. Maybe let's try to ping from the loopback. I'm going to ping from the loopback to the loopback. Okay, we have connectivity. And I am sending those packets from 2.2.2.2. If I were now to say that 2.2.2.2 is a malware infected device, I could possibly go over here, add a network list. So I can add objects, I can add lists from here, or I can go back to objects and object management. And let's say that I want to add a new network object. I'm going to say R2L, and this is going to be the loopback that I know is bad. Okay, I'm going to add it here and then select as a condition. I could also choose a zone, like to say that if I see these arrows on the inside, I want to add it to a blacklist. But if I don't select a zone, it applies to all zones. So no matter if I see these arrows on the outside, on the inside, or anywhere else. Okay, and with this in place, this is how I blacklist this single address. So if we save and push this change, we should see that the communication is no longer going to be established. And we will also take a look at this in the log messages. Okay, logging here is by default enabled. for networks URLs, and also for the so-called DNS policy. We will talk about DNS policy in just a second. Let's go back to the CLI. Let's try to ping once again. Okay, at some point we will eventually lose connectivity. Let's go to the FTD. Let's say clear connection. No connections. But I finally see that this communication is being dropped. We take a look at this in the logs. It is going to tell us that it is going to be due to the security intelligence evaluation. It's going to be this engine what caused those packets to be dropped. So it says 2.2.2, this is bad. And you can also take a look at this under security intelligence events to kind of like separate these from everything else. You will see just one entry. You can also take a look at the details like with regular logs. And it is also going to show us the category under which this address was assigned. So this is the initiator, source of the session. We know it is bad. We have a match here. So we drop the packet immediately. We don't even evaluate the access control policy rules. Okay, if you want to use manual lists, this is when you will have to build a text file and specify your addresses or URLs, one per line. And I'm going to show you this when we get to the DNS policy. Text file will have to be uploaded to the FTD and the policy will have to be updated with this new setting. Okay, so what's the purpose of the DNS policy? The DNS policy is essentially how you enable or just activate domain support for security intelligence. So without a DNS policy in place, you wouldn't be able to match communication based on domains. You would be only able to use IP addresses or URLs. And now the reason that the DNS policy is kind of like separated is that domain-based blocking works by controlling DNS communication and not the actual data packets. So the goal of domain blocking is going to be to cut down on DNS resolution, where a DNS query is sent for a website or just a domain that we know is malicious. In the simplest case, we will be able to just drop this query, which of course is going to result in not getting a reply from a DNS server. So this way the client is not going to be able to figure out the right destination IP address, and there's going to be no communication to inspect. So no traffic is going to be eventually generated because the DNS information was not obtained in the first place. Okay, same as with other types of security intelligence rules, we can use whitelists or blacklists. And as in the previous cases, the Cisco populated blacklist or whitelist information is going to be evaluated first before the custom entries. Okay, now in terms of the actual actions that we can configure in our DNS policy, one of them is going to be to block. I mentioned that, but there are also going to be two more. I can say that I want to whitelist the traffic, which is how I'm going to forward the DNS communication to the access control policy. I can say monitor, which is how I tell FTD that I want to evaluate the packet against other rules in my policy. Plus, I'm going to log the traffic. And I can finally say that I want a blacklist, in which case I will be able just to drop the original query, or maybe I'm going to reply with the non-existent domain DNS message. So this way, telling the client that this particular domain in question is not valid, is not associated with an IP address. Or I can send a spoofed IP address in my response. So the last two actions, it's like FTD spoofs a DNS reply, either telling the client that the domain does not exist, or it provides the client a false information. Security intelligence is by default using a system-provided DNS policy. We can customize this policy or we can build a custom one. If you want to build a custom policy, we'll have to go to access control, then select DNS policy, configure our roles, and finally activate this policy in the ACP. So maybe let's quickly take a look at this. Let's start with policies access control DNS. Okay, I'm gonna build a custom policy. So I'm gonna say add the policy, my DNS as its name. And this is where I can add my roles. As you can see, I have two sections, whitelist and a blacklist. When I click over here, well, I'm gonna add a role that is gonna affect all inside, outside DNS flows. So this is gonna be my source zone. It's gonna be for all networks. And then under DNS, okay, I'm gonna add my custom list from here. I could also do this from objects and object management, down to the security intelligence objects. Okay, the type I'm gonna say is gonna be list. If I were to select the feed, I would have to provide a URL of the external feed server. I'm gonna say that this is hacked dash domain, just the name for this list. Now I'm gonna create a local text file where I will add a custom domain, let's say hack.com. I'm gonna save this file. I'm gonna choose the file. Okay, say upload. It says number of DNS interface 0. Right, maybe let's just go ahead and do this. Let's cancel this configuration. Let's go to the policy access control. Let's first assign this policy under our ACP. So go to the Security Intelligence tab, select this new policy. The logging should be enabled, which it is. Okay, let's just save and deploy. I'm gonna do this first. And we will then go to the objects. And I'm gonna add a list from here. So DNS lists and feeds. One more time. H2. Okay, I'm gonna put it over here. We'll save this file and then choose it once again. All right, now it shows me that those entries are here. I'm not quite sure why it wasn't showing as 0 before. Looks that every single file I uploaded was actually having the right config. So we've got the list in place. We go back to the policy. The policy is now assigned. I'm going to add it. We will add a role. Again, this is going to be from the inside in-out DNS role name. And the file was called new hack. This is going to be my DNS list. And for the action, I'm going to say that we will use a sinkhole. I will have to add a sinkhole first. I'm going to say add with this. We will save. And then we will go under objects, object management, and add a sinkhole here. So I want to send a reply back with a spoofed address. And let's say that my fake address is going to be 2345. And for IP version 6, it is going to be something like this. Just the spoofed address, doesn't really matter. We will log, block and lock connections to this sinkhole. And the type, I'm going to say none. I could classify this sinkhole as one of those three types, but we will not be doing this. I'm going to add it. And then we'll go back to the policy so I can select it as part of my action. By the way, notice that the role was added to the blacklist because the action configured here, the main not found, drop, and sinkhole, this is all part of the blacklist action. We can now select the object from here, save push this configuration. And the result is that I should get a reply, fake reply from 4. I'm going to make 4 my DNS server. The router is going to act as a client. We can easily do something like this just by configuring the name lookups. Maybe let's just first configure the server on 4, IP DNS server, IP host hack.com is gonna be 4.4.4.4. So router 4, this is our real DNS server. It is configured with a single entry for hack.com domain pointing to itself, to its loopback. Versus router 2, I'm gonna say, this is my name server, router 4, and enable DNS lookups. So when I say ping hack.com, it is now trying to do the translation. Okay, one more thing that we will still have to do here in the policy, but this time in the access control, is going to be, of course, to allow DNS communication. Because the problem now is that I'm dropping this DNS traffic in my access control policy. So I will add a simple rule where I will say that I want to allow all DNS communication. It is going to be UDP 53. And let's also add TCP, like for zone transfers. DNS, this is going to be the name. Okay, any, just the port numbers in any direction. So one more push to the firewall. Right, but the DNS policy is now active. Maybe let me first test it with another entry. Like let's add an entry for good.com, which is going to be 4.4.4.4, show hosts. So I should be able to get to good.com. But not to the other domain. Well, let's take a look at the access list here. Do we have the DNS rule in place? Okay, now we have it. Okay, so I can get to this domain, but when I try to get to hack.com, we see that a spoofed reply came in. It is pointing us to 2, 3, 4, 5. And I can confirm this in the event viewer. It says that the traffic sent to 4.4.4 from the initiator was sinkhole. This is DNS communication. And when we take a look at the details, it is telling us exactly what's the category under which our request was matched against. So no hack, this is my custom entries for hack.com and hex.com.